right, we're going to talk about traces, and this is going to be the big piece for this lecture that we're going to build on in the pawn, and then we're going to basically leverage the code we wrote in multiple different ways. Excuse me. So trace types. So basically, there are different types of traces that you can do, and basically it's by object height. So right now they've got this object is being, you can set up custom collision preset, and right now the object height is world static. But we're going to be playing with things that are going to be world dynamic. Um, they're going to show you when, so basically there's a hit result structure that we will be working with. And it has a node called break hit result that's going to give you all the data that you're going to need. Typically it is, do you have a blocking hit? Where's the location? The normal and the hit actor are pretty much the big ones that you're going to be using. You can go in detail like wait, hit bone name, face index, trace start, where the trace start and end type stuff, for if you need that for other things. But so there's a lot of information shoved into here. You're only going to be using like 3, 4, 5 things at most. And for our code this week, it's just the hit actor that we're going to be using only in our code. And here is a line trace for object. This is going to be the primary way we're going. And it basically, you'll put in a branch return value out here, so you won't even have to worry about using the blocking hit. And then the out hit structure is here. Again, here is the hit actor that we're looking at. For our purposes, what we're going to do is we're going to take the hit actor and we're going to cast it to the BP Interactable class. And from there, if it's that class, then we'll call a function called on on use. And that we'll set that up in the parent to basically print out something into the console window, and then from there, all the children will be able to leverage that code, um, basically the structure there, and then leverage on do to do other things. There is again the line trace for object. So start point, end point. Think of this array that we're gonna trace through. Start point, end point. Object types we will throw in trace for object actors nor again the self will throw in here. So this is for multiple actors. Up here, will be there's a single version of it that we'll use. You can use by trace channel, and this is stuff you can set up. Again, look at how the channels are set up for collision and whatnot. Multi-line, get multiple actors. Shape trace, so set up a box to be capsule, box for object. And then there's some debugging here we'll put through here. So I'll point this out in because we'll actually use it. Spawning, destroying, we've seen this already. Spawn a blueprint, spawn an actor. Destroying objects, it's destroy node. No, we can attach an actor to a component. So what is the actor? What is the component? For skeletal meshes, there are socket names. So sockets will basically are things that we can add to skeletal meshes. So typically like a weapon attachment point or on the weapon, the end of the barrel will be a socket, and we can reference those points on the mesh to do things. Play sounds, we've done this. You've done spawn and emitter, destroying component. Basically, if we want to destroy an emitter, we've destroyed the actor, but we can also destroy the component of it. Again, when we spawn the emitter, there's a return value that we can assign to. And animations, it's really not much. Again, we play with timelines, set animation, view target with blend. To actors, view targets, usually a camera, target player controller, blend time, how it takes to complete the blend function, type of function used for blending. So this is again removing actors around using this code. Timelines of variables. Huh? We can assign them to be. That's that. I didn't think about that. Uh, tick event and delta time. There's delta seconds. basically this is the tank. This is the time that's been elapsed. Again, right here, this is moving down the x-axis. At actor world offset. This is something you've moved actors around, so it's no big deal. Interp 2. Uh, Basically, this is basically where you are, where you're going, how fast are we trying to get there, and how fast how much time over that are you going to go? Are you moving, and what's the speed you're moving at? They've got an example here. Here they're basically saying, hey, um, the delta time has been the delta seconds. The display health is the current. The real health is the target. And then what is the display health? So this is again like if on tick, basically we're updating a health bar. Yeah, we've been damaged. We're going to slide our over a second. We're going to go from where we are to where we should be. So a lot of this is going to be math modulo. So if we divide, when we're doing integer math, when we divide, we get only what is the full value of what how it. So, so 7 divided by 2, we're going to get a value of 3. And this is just integer math. Again, floating point, all that is a different ball game. When we use the modulo, we're going to get just the remainder. So 7 divided by 3, we get an answer of 1. We got some more module examples here. Clamp, this is basically keep it between these two values. So here's the value, the max, min. If it's below the minimum, it gives you the minimum. If it's above the max, it gives you the max. Otherwise, returns back the clamp. And it has different versions of it for floats, integers, and whatnot. Min max, so basically we put in a value. We ask what is the minimum of the two. What is the minimum of the two? Max, it basically gives you the max value between the two. Set material, we've used this already. The static mesh component. Set material, we've used this already. All right, so enable input is an odd duct, and there's also a disable input as well. And what it says is that this actor now can take input events such as keyboard, mouse, and gamepad. So target actor that will have its input enabled, the self value is target the blueprint that contains the node, and then player controller, the reference to the player controller in use. So which act, and this is you need to be very careful with this. To be quite honest. Because this breaks the normal flow of how things are behaving in Unreal. So basically, the idea behind this node is that you go into a trigger, and then object has the ability to respond, has something has an input enabled on it, that this now turns it on, and when you leave the trigger, it then turns it off. Here's begin overlap. The other actor is the player controller. Basically, is setting enable on the object. And again, it's not showing what it can do, but basically it's what player is enabling, disabling. This is not how you would normally do things per se. I know this is being shown this way and shown as being set up, but ultimately, um, yeah, this is one of those. I wouldn't be enabling and disabling input on an object and then that takes special input. That I mean, it's here, you can do it, but this feels not the way you would want to go about doing it in the engine. It's here, but not sure. And then this is basically getting a player controller and telling it to throw a widget onto the screen. It's not necessarily, again, set input mode in game and UI, not necessarily the way that you would want to go about doing this. But there's widgets here that it's available, like for smaller applications, smaller games. Like a mini game, like a Flappy Duck. That this might be useful, but not necessarily in a bigger game, more structured game. So it's here, but do you really want to be using it? I'm not really sure. I would be using these nodes. I'm not going to bother. Again, we've seen teleport. And then the one that is random point bounding box. So basically, the origin is basically let's just jump to it. Here is a spawn area from the persistent level. So this is a begin play in the level most likely. Um, get actor bounds because we're asking the object what is it bounds. We get the origin and here's the random point in box, and basically we're basically spawning items into this area. So again, they've got a collision handling, again game item, whatever game item happens to be. So select. This is again, if you've got multiple variables, then hey, then you can go in with an index, and then throw into here. Here they've got 3 different spawn points, and they've got an spawn point index. Cool, but I mean, if you had an array of vectors of spawn points, I mean, ideally you would this would be something would hold an array of spawn points. You'd ask that array for a random index, get a random index in that array to get a random spawn point to spawn someone in. Or in this case, you could be jump. This could be advancing um, down each time you go through. How you do it again is up to you. But there we have seen. Here's a select version. Here's another one. There's a difficulty like easy, hard, normal, and then here is giving back an integer for those values. So let's go into your document now. So basically, you're going to continue with the third person you've been using class. We're going to make a new folder, Lab09. We're going to create a new level and a third person BP09. So let's do this right now. I've already created the level. Let's just go to the content draw, and we'll make a new folder, Lab09. We'll just go in here. Go into third person blueprints. Again, here's the third person. I'm just going to copy it into this folder. Copy here. And this we'll rename to BP Lab 09 pawn. I will actually go to the world settings. Make sure that you have a third person game mode. It's not going to do anything. We'll set this to the 09 pawn. We don't need a HUD for this map or anything else. So now that is, we'll just file, save as, save current level as, go to Lab 09 folder, Lab 09. So we pretty much got this, for our basic setup. I know that I'm going to need 2 cubes. So I'm going to go to shapes, I'm going to go to cube. And I know that I need this about size of 4 across the board. And I want to put it at negative 500, 500, and at 200 to sit on the floor. I'm going to put this at 500. Oh, we're looking at the level. Huh. I'm going to put it at 500. There we go. No. I'll set it to negative 500, and then what I'll do is I'm going to just flip this around to do a 180 on it, so that I'll be looking down this way with the level, and that'll be important as I build some things that we have this shade here. I'm going to grab this cube, I'm going to duplicate it, and I'm going to put this at 1,000, not 1,000, 2,000. And put that at negative 500 one more again. I'm going to make this again. I'll make this, we'll do this 8 across the board, and that will make this 400. So basically have another cube, and we'll use that later on in this assignment when we start building, when we build stuff. All right. All right. The first class that we're going to build is basically a blueprint class called B. It's going to be an actor, and it's going to be a BP Intractable. And I'm basically going to go, let me bring this in. Let me get the pawn class. There we go, good. So for the interactable, basically I'm going to add a cube here. Grab its details. I'm gonna do 0.5. Man, this is 2, and I think 100. Yeah, that's what I needed. I'm basically going to give this the material of the hex tile, just so I have something to look at. And I'm basically adding an object here so I have something to look at in terms of my object. All right. The important piece of this class is in a function that we're going to create called onUse. And basically what we're going to do here is get a reference of self, get its display name, and we're going to append this with another string, which we're going to basically going to be is being used. And all we're going to do in this right now is going to print out that string. And this is going to be our basic, like, hey, we know that this is that this is kicking off by this function here right now. All right, so we're going to save that. We're going to go into the pawn. In this case, we're going to go down here and we're going to build the interaction piece. So we're going to go in, right click, thank you, keyboard E. So we're going to jump down to the E. We can find it. There we go. And just for the sake of argument, we're going to print out a string. We're going to do E colon, just so I know that the key press has happened. All right. From this, so from here, we're going to basically, this is the line trace by object. Yeah, line trace for objects. There we go. And we'll start with, we'll put this down here because we need to plug in the beginning and the end. All right. So right now, what we're looking for, we're going to use the get player camera manager. And we could have gone with the follow camera as well, getting its world location. That would probably have helped. And we're basically going to get actor location. There we go. And that's going to be the start point. I am literally going to copy and paste this because the endpoint is going to be the actor location, but we are going to, again, move this out a little bit. In this case, we're going to get the get actor forward vector. All right, so this is where we need to start building some variables. So the first one we need is basically the check distance. And that is going to be a float. I'm going to compile, and it's yelling because I don't have an endpoint here just yet. Is it still there? We can put in a value at least now. And 6,000 is going to be our value that we're going to start with. Basically, we're going to take the check distance, and we're going to multiply that to get the forward vector by our check distance. So that's the delta from the start point to the end point, and we'll pull this back, and then we will basically add, do it from the top one. We'll add, and I'll plug that in there, and that will be our endpoint. The last thing that we do need to do is object types. And this is going to be make array. And we want not world static, but world dynamic. So this is basically the start of our ray trace. And so when we get an out ray trace, we'll get an instance of this out hit. So we want to break the hit result. And we'll open this up to get all our values. Again, the first thing that we want to do is do an if statement and use the return value here. And what we'll say if we've got this is true, what we want is to take a line out from our hit actor, and we want to cast to BP Intractable. And then as in BP Interactable, we want to call on use. So this is where this is actually happening. And there's probably more places we can do to debug. I'm going to use this for right now. I'm going to open this up a little bit one more time. I'm going to turn on the debug. I'm going to turn this on for duration. I'm going to put this 1.5 because 5 seconds is so long. So after a second and a half, these lines, the lines that are generated, will disappear. So let's compile, and let's go back into our level, save everything, go back into our level, and we are going to drop in to level the BP Interactable class. I'm going to press play and go up to it. And you see that it basically, where the hit is happening. So it hits that first. Okay, that's cool. Let's make our first child of this, and we'll go make a child of blueprint class. And this is going to be BP it goes boom. And we'll open that up. And basically the cube, and I should go back to the interactable, and this should be named model for our purposes. So we're going to recompile, and you'll see that that is updated here appropriately. The big thing is that this is just basically going to be using there's a laser pointer material that we're going to use for this object. And it's pretty much at this point, it is just on the functions we're going to override on use. We will keep the parent on use. And for our purposes right now, it is going to be like, hey, spawn emitter at location. This is going to be play sound at location. And then this will be destroy the object, destroy actor. Again, we'll select the sound, the explosion cue. Here, this will be the explosion. And I found that value, I think 2 was, I needed the object, I needed a bigger explosion. 1 was like not didn't feel correct. So we are going to get actor location. Actually, I'm just gonna plug that one over here. But I'm gonna do get actor transform and break this link. Again, we've done this multiple times. We'll plug in location and into the rotation here. Again, I want to play with the scale independently of that. Play the sound and destroy the actor. We'll compile. Let's go back in and we'll drop. I'll drop put you over here, and then we'll put one up here for the sake of argument. And we'll put one up here. So again, we will eventually get up. We will eventually get up here. So don't worry. So we go up. You can see the interaction, and then again, let me bring up my volume. I'll replay the level. And there you go. All right, so far good. Let's go back to our content draw. So here's BP Interactable. We're going to make a new child class. Again, the next 3 entities we're going to create are going to be child of this class. So create blueprint class. This will be BP lamp. I'm just going to create all the entities right now. This will be BP elevator. And then the last one we're going to have is BP call elevator. All right. So let's go with the lamp. Let me save all of these. Let's go to the lamp. We're going to start with the model, and then we're going to put this back at, actually make the size of 2. This will be at 0. The static mesh will be SM lamp, and there'll be the lamp wall mesh specifically. We'll set the material back. If we type lamp, you'll get the material. Professor Wallet cannot spell today. And that's what we need to basically in terms of setting up this model. We are going to add a point light. And we'll add it to the model. And I know this was about 25 forward and again 75 up. Is that too much? That is too much. Oh, there we go. 1. Actually, let's just put a scene root. There we go. So yeah, there we go. So I was having an issue. The point light is being scaled somehow by was being scaled. So we only wanted 25 and 75. So have it part of this default scene root as opposed to next to the model. Light color, we're going to set this to yellow, so it'll be 110 for the RGB, so no blue. And what's the, like, there we go, 200. We'll bring the attenuation down, so it's not massively huge. We'll go 250. So we'll compile. Let's go to the, the function we're just basically using on use in this case. Again, we're going to use the parent on use. We'll grab out the point light, and in this case, we're just going to use toggle because we're just trying to show activity. So basically, when we use the object, the light will toggle. So again, I had this shaded area for this purpose. So I'll put the lamp right here. -3, 500, and 125. And we can go run into the, you can see that I am, so I'm toggling the light on and off. So stuff that we've done before. All right, the next entity that we're going to build is going to be the elevator. And this is going to get interesting because, so let's start with the model. We're going to duplicate this model. And this model we're going to name as Phantom. We'll come back to that one moment. We know that in the document, I believe I said 1.5.2 is the size that we want, and this is going to be at 0. Now the Phantom is going to be 1.5.2, but we're going to set this at 200. The mesh, we want a translucent material. Where is it? Here we go. Sample translucent is what we want. That's not what we want. Here we go. M shader simple translucent. That's what we want. There we go. All right. So the other thing that we would need to do with this model, this component, is to go to its collision, make sure that it doesn't generate any overlap events, no on character step on, and this is going to have no collision. The other piece is we want to turn on hidden in game. It's a rendering component. So this is basically essentially what we've made is a gizmo for this elevator in the editor. Go compile. And so I'm actually going to go into the level, and we're actually going to drop in the elevator right here. Come on. There we go. In this case, I didn't have to rotate it. In previous, I've had to rotate it a couple times. I'm going to put this right up next to the wall. And what we're going to do is basically, this is going to be the start point of the elevator. In fact, I can actually go into the model itself and be like, hey, it'll go -10 here. And then up here, we can go about 400. Or if we want to, again, here we've got like maybe like a little lip. We'll go maybe, hey, 390. Or maybe even 380. So there's a little lip. So it comes up and there's a little lip stepping up on here. And so the idea is that this is going to be the start point of the elevator, and this is going to be the end point of the elevator. And that's again something that we can do for our level designers for building them tools that see fit for our uses. I am going to duplicate I'm going to grab this model. I'm going to duplicate it. I'm going to bring this over here. Nope. Nope. What I've got, I'm still selected in here. There we go. So I ended up duplicating the component, which is not what I wanted. I'm going to duplicate the whole entity. In this case, I'm going to grab the whole entity over here. I believe, again, 390, we just happen to be that on the other side. And now I can grab the phantom over here, and I can pull this over. And I can bring this up a little bit taller. There we go. So basically, this second elevator is going to go from here all the way up to there when it moves. So, okay. I'm going to save everything just so that and I'm going to close what we don't need open. We don't need the pawn. We don't need the interactable. All right. I need to make sure that so there are three. So the elevator needs three variables. The first one is going to be turn delay, and that's going to be a float. The next one is going to be has been activated. And this is going to be a Boolean. And the third one is basically going to be the lift start position. And this will be a vector. All right, I'm going to compile so I can access these. The return delay, I'm going to set the default value of 2 here. I'm also going to make this editable instance so that I can change this in the editor as I see fit. Has been activated, this is going to start false. And then lift position we're going to get at begin play. So let's actually go into the event graph, and we can get rid of all of these. We don't need to worry about parent begin play. But in this case, we're going to set the lift start position by grabbing the model is what we want, and get relative location. I mean, we could get the transform, but if you were doing both the rotation and the location, you definitely would be getting the transform, but we're just doing the location for our purposes right now. We'll plug that into this value here and assign that there, and we're good for begin play. All right. The next function, we want to create a function which we're going to call move lift, and it's going to have one input, and it's going to be called percent, and it will be a float. This is where start lift position is going to be useful. the phantom. We're going to get that and um, we get the relative location. Again, we're working all in relative location. And then from percent, we can then use a lerp. And specifically, we're going to use a lerp vector. And the start position is going to be A. The phantom's position is going to be. Pull this back. And then all we have to do is with the model, we're going to set its relative location. And this return value is going to be that new location. And then we'll plug in across. And we can bring this in a little bit closer. And that's all that move lift is going to be. Now it's going to take a percent from 0 to 1. It's going to plug that in. Basically, this is B minus A times the alpha, then adds the A back in, and then that's the return. That's essentially what the return value is. Now we almost used lerp with the sliding doors. The only reason we didn't because we knew how far we were going to slide. So we didn't need to create, start position, end position, all sort of things. But here with this lift, hey, it's pretty straightforward in terms. We place the lift here, set its end value with the phantom, and off we go. All right, so we are good here. We're going to compile. Let's going to go back to the event graph, and we're going to create two events here. The first one is going to be add event. It's going to be activate lift, and the next event is going to just be the return. So basically, we have two events to call when we want to start when we want to start moving the lift up and have the lift return back down. We are going to use the has been activated here. We're going to set it. This will be turned on, and we'll explain why this is in one moment. But these two, where we're going here is going to a timeline, and we've used a timeline before. And we will plug in the activate lift chain to play and return lift into reverse. And then we can double click on the node, add a track, which will be a float track, which we'll call percent. We're going to do a length of 2. You can do a length of 3, but I'm going to do a length of 2 for our purposes. We're going to zoom out, so we got 0 and 1. I'm just going to make a key to the float, to curve. And I'm just going to go in and make sure that the time here is 0 and the value is 1. And then on the second keyframe, again, 0 keyframe is down here. And I deleted it for some reason. Well, that's weird. So time is going to be 2, the end of the timeline, and then the value is going to be 1. So we've got our 0 to 1 through here. So when we run the timeline up and back, that's going to give our percentage. So we'll compile. We'll go back to our event graph, and now we can grab the move lift functionality. And we literally will plug the percent into here and update into the move lift. All right. Now, when we get to the end of the timeline, finish is going to get called off. And what we want is basically when we're at the end of the timeline, so we've activated it, we want to delay a few seconds and then have the lift return back to its starting point. The problem is that finish fires off at the end. And when we play, it's going to fire off at the end. And when we tell it to go in reverse, it will fire off again, and we get to the start. This is where the has been activated is in play here now. So first we'll do off of here, we'll use an if statement or a branch and grab our Boolean, not set, get, and we'll plug this into here. So we've got this going on now. And if this is true, then this is where we'll set has been activated back to being false. We'll call the delay. And again, here's our return delay variable, and we'll plug that into the node. And then finally here we will call return lift. Okay. So without this Boolean check here, basically a delay would happen and then return would get called, even if we were at the end. So it would call it again and again and again and again. So it would be this infinite loop of calling return lift. And what would happen is that we would call activate lift, would get called, and then somewhere in the middle of that delay, this gets called and the lift returns back down the bottom. So that's um, if you want to take out these two boolean these nodes right here and just call, and you'll see that in action. So we're going to compile. The last thing that we haven't done yet is just override on use, and on use is going to be pretty straightforward. This is going to call activate lift in our case. So I'm going to go in and we'll go to the level itself, make sure we save everything, and we'll press play. And I'll go up to the elevator. I'll use it, and you can see that we've gone up. And then we blow that one up. We'll use this lift. And then we'll go up, we'll blow this one, and turn around and be like, hey, where's my lift? And this is where the call lift element entity is going to come into play. So we're going to go back. We're going to go to the call elevator. For the model, we're just going to go and change this to the hex pulse so that it's something different from the other. And then all we have to do is go, and the other thing that we need to do is create a variable, and this is going to be the lift reference, and the type we're going to make is going to be of the BP elevator class, and it's going to be an object reference. We'll compile, and then now we just go to the event graph for on use. And so in this case, I am, again, keeping the parent. This is basically just saying that something has been in use. But I'm going to take the lift reference. I'm going to get that, and I'm going to ask is valid. So basically what I'm doing right here is basically verifying that, hey, the level designer actually put a value in. This is going to go into an if branch or if statement. And if that's true, basically I'm just going to get the lift reference again, and we're going to call activate lift. Ooh, grab you and bring you in a little bit closer. And then we're going to have some fun. We're going to use, so if we didn't get a valid, we're going to use a print string. And I'm going to go, hey, dummy, level designer. And I can say this, I can write this because I am a level designer, so I know what we will do. You forgot to assign an elevator this caller. There we go. And we'll combine, and then we'll go and we'll save this. And in the case of our level, in this case, we're going to go start down here. So here is the caller. And again, here is, did I set the variable? No. So the one thing I did not do is I did not make this editable instance. Oops, we'll compile, so that will be, save everything, go back to the level. Now here is what we need. We know this is going to be elevator, the first elevator, which is what this is the one. And this is elevator, the second one. Literally, I'm going to duplicate this. I'm going to revert it so it has none, so that we have a version, I'll leave this here, that doesn't have a reference. And then I'm going to put this one up here. No, that because it's a size of 8, it's going to be 800 at the top. And this will be referencing elevator 2. And again, what's nice, because I said the variable is of type BP elevator, it's only going to show me the instances of those in the map. So it's not going to show me the booms. It's not going to show me the other interactables. It's only going to show me that particular class. That's a nice. This is a nice feature of Unreal, by the way. So here's our level. It is blow all the red things up. Is what our game apparently is at the moment. So we go over. We interact with that. We blow that one up. Ride the elevator up. We know that we can blow this one up. We can see that we're yelling at our level designers now. And then over here, we can call the elevator back up. I'm going to ride this one over. And this one will definitely blow up. You can see as it goes down, we'll call it back up. Oh, missed it. There we go. And there we go. We can now come back down through the level. And that is our level in a nutshell. This is what our assignment is. Your assignment is in a nutshell. It is we're going to create an interactable object and then use it for multiple different purposes. An entity that will blow up. Here's the light that will turn on and off. A lift. Again, we can call the lift back up with another object. And again, this has an interesting feel to it already. Even with just these primitive pieces we're dealing with already. Again, we can jump all the way down if we want to. But with these pieces in play already, we've got something interesting that we can be doing. I've gone through this pretty quickly, pretty fast. Let me make you over here to get you out of the way of the walkway. There are any questions about the assignment and what we're doing? It's pretty much building upon what we've done before. Like definitely all that inheritance we've done. You've done that with the coin collection game already. Again, all of them are basically all of the classes like the call elevator. I mean, we could take out the unparent on use in this case. It won't say that it's being interacted in there anymore, but it's perfectly fine. We could do that with the elevator as well. I mean, this is just basically saying it's being interacted with. But we could be doing a lot more with our parent class. So, any other questions before I turn off the... Your lab goes through in detail. The document is now up on... It is correct. I got to make an announcement for the other group. But the lab document is there with showing graphs, showing settings, whatnot. Particularly, again, the big one is that, again, here's the elevator and here is the phantom piece that's setting the endpoint. That's one of the interesting things this lab is doing. You've done the inheritance before, but now we're doing this, you know, how would you take that basic piece and just run with it in multiple different ways? And there's extra credit across the board in this. If you want to make more children of the Intractable to do different things, interact with other things that, you've got more stuff going on, go for it. Go for it. That's all it's all fair game at this point. All right. Any other questions? No? Okay. So I'm going to end the recording here.